Welcome to the summit. Thanks all for joining. My name is Jihun Kim. I'm a senior data analytics and machine learning as part of the professional services in Europe, helping customers in healthcare and healthcare technology space. And with me, I'm happy to be here with Chris Suter from UK National Health Service User Experiences, most commonly known as NHSx. And Chris is here to tell us about really cool use case on using ML services on AWS and how everything comes together to support their mission. So what will you hear from us today? So I'm going to start off by going over the landscape of document processing and some of the challenges that our customers are facing today, and where Amazon A2I and TextRack comes in to do the undifferentiated heavy lifting so that you can focus on what matters to you. And then Chris will tell us about how NHSBSA is using DML services to support their mission. So a recent study showed that the upwards of 80% of the enterprise data today is unstructured. Now that's a lot of data just waiting to be processed and extracted for the valuable business insights. Now these unstructured data could be people-generated content or human-oriented content, so things like files, it could be PDFs, things like scanned images, perhaps. But the key takeaway here is that the documents are still predominantly used across the industry today. Things like in invoices, statement of accounts, healthcare records, and prescriptions. So how are the businesses tackling this problem today? The majority of the document processing is either done manually, which could be quite expensive and resource intensive, or through OCR or rule-based templates. Now with manual processing, because humans are involved, there's relatively high chance for errors to slip in, and it could also be quite expensive in both time and effort. Now with OCR, the optical character recognition, which has been around for a really long time, now it can read simple documents and it usually results in a flat bag of words, which often requires a further processing to really make good sense out of it. Now people sought to improve upon this OCR experience by introducing rules and templates. Now these would require development teams and the management team to take really time to go through the process as a part of their business workflow. And to make these really effective, it would require a quite non-trivial amount of the time investment. Now, but the real challenge with the rule and template-based system is that in its flexibility. Because these are based on the rigid methodology, if there's any requirement to be changed, it's hard to be adapting to the ever-changing needs. So when we launched the Amazon A2I and TextRack, we wanted to alleviate some of these problems that our customers were facing. The Amazon TextRack is a fully managed machine learning service, and with it you can extract printed text, handwriting, or other data from scanned images and documents. But it goes beyond just the OCR. It understands, it can identify and extract data from forms and tables. And all of these, you don't require the ML services to operate this. And so that you can really focus on what matters to you and not really worry about the undifferentiated heavy lifting. And along with the text forms and the table extraction, the A2I is natively integrated with the TextRack for the human in the loop. And towards the end of last year, we introduced the support for the handwriting recognitions, along with the support for the additional languages such as French, German, Italian, Portuguese, and so some of those languages are supported now. Now, all of these features that I outlined are just out-of-the-box functionality when you use TextRack. But since we launched TextRack, we've seen a number of use cases emerged, and I'd like to go over a couple of those use cases with you. Now, one of the such use case is in indexing and searching documents. You could have a business requirement where you need to search for the occurrences of a specific word or a concept across tens of millions of documents. So from the left-hand side, you have documents being coming in and saved onto an object storage, in this case an Amazon S3. And then a compute service would call upon TextRack for its inference via the API call. And all of these will be event-driven so that you can really only pay for what you use. And once TextRack comes back with an output, people either save these results in a Elasticsearch clusters, or more commonly, we're seeing the Amazon Kendra being used. Amazon Kendra is a fully managed, highly accurate, and intelligent search service powered by machine learning. Now, another common use case is combining with natural language processing when you process your documents. Now, this is really powerful combinations. Let's say you may want to look at just beyond extracted text, but look at into the entities that could be defining some of the concept that you might be looking for. So from left-hand side, you still have the documents being ingested in, save them to object storage, TextRack being called, and this is where the natural language processing integration comes in. You could use services on AWS such as the Amazon Comprehend or Amazon Comprehend Medical, and these two services look into the extracted text in that document and going to draw the concepts behind some of the entities. And once these entity drawn is done, you can also save into a Elasticsearch clusters or use Amazon Kendra, or you can even fit it into a electronic medical record system, depending really on your use case. Now, these are some of the ways that our customers are using Amazon TextRack, but customers also ask us, how do we incorporate the ML predictions into our business workflow? And your requirement could be that you might have a regulatory requirement that you would have to have auditors to review the outputs. Perhaps you have some sensitive documents that you need to have the reviewers to audit the outputs, perhaps even multiple times. And this is where the A2I comes in. And A2I is short for the Augmented Artificial Intelligence. You can build the human review workflow for auditors to review the outputs that you may need. And you can also allow the human reviewers to step in where the machine learning, let's say, is not making a good enough predictions. And A2I also comes in with a built-in workflow for common use cases such as the text extractions and the content moderation. But if none of these fit your need, you can also create a bespoke workflow with your custom machine learning model to examine your outputs. So let's look at how the A2I might work. So from left-hand side, you have documents being coming in, and these will be ingested into an S3 bucket or some kind. And once it's been ingested, you will call upon one of the ML services for inference. Now, this could be any of the ML services that we offer on AWS, or it could also be a custom machine learning model that you developed. But in either case, you would have a confidence threshold that you will set, and this is where the paths diverge. Now, if you have high confidence, you can pretty much consume the outputs on your downstream application. But for low confidence predictions, you perhaps want to have reviewers to audit the outputs. And once the reviewers come back with their reviewed output, you might want to have the A2I to consolidate the result. And you have a choice to either to save it onto an S3 bucket, or you can use that output to retrain the model so that the machine learning model improve its performance. In either case, you would use the output in the downstream application. But the key takeaway here is that the A2I does the end-to-end orchestrations from the assigning the workers, contacting them, and notifying them upon jobs being available, and upon the reviews being done, consolidate the results and save onto an S3 bucket. A2I really covers the undifferentiated heavy lifting so that you can just focus on the auditability of your business workflow. So let's quickly take a look in action. I have a quick demo here, and on the left-hand side, you have a prescriptions been coming in, and this is a sample prescription. You see a sample patient name, a Rachel name, along with her age and the date of birth. You also see the pharmacist stamp on the top left-hand corner, and towards the bottom, you see the prescriber's signature along with the date of the signature being done. And what I'm going to be doing here is running a script to ingest this image onto an Amazon S3 bucket. It's an object storage service. And once it's uploaded, to create an A2I to be incorporated into the workflow, you need to first create the human review workflow. And once the workflow is created, you assign to a group of reviewers. Now I'm going to launch the script so that I can create the human review workflow. And towards the end, it's going to output the worker portal so that the workers can sign in and start looking at their task assigned to them. So I'm going to copy off the URL and log in as if I'm one of the worker. And as a worker logging in, I'm creating the landing page. I see a quick key information about A2I. And notice that there's no jobs available here yet. The jobs is 0. Is it because I created the workflow, but I didn't create any task assigned to them? So I'm going to go back to the Jupyter environment and then start the TextRack calling. So with that image, I send it to TextRack. TextRack does that inference, and the output is sent to A2I. So if I go back to the worker portal, quick refresh, I have a task assigned to me. And going in, you can see the image showing up on the left-hand side. And the leftmost side, you have a customizable instructions that you can fit according to your the organization need. And on the right-hand side, you have the key value pairs. And each of these key value pairs, when you click on it, you have colored boxes superimposed on your image, so that you can really see where TextRack extracted these key value pairs. So now going through some of these key value pairs, as I click it, I can see the color box popping up on the left-hand side of the image. Looks like a lot of these are just correct. Date of birth is spot on, and I can see the age 32 correctly identified. Next one is the title, the first name, and the address. I can see it's all correct, but I'm going to switch up the anytown towards the end. So I'm gonna type in the one long road and anytown, so address in the city being swapped. And I can see towards the bottom the endorsement looks correct, okay to me. And then move on to the last phase, which is also empty field. So I'm going to click on the value is empty, and then I'm going to click submit to finish that task assigned to me. Now what I'll do is jump over back to the Jupyter environment and consolidate this result and do the quick difference between the TextRack output and the A2I output. And I can see towards the bottom here that the address has been changed, and I can see the before and after the A2I coming in. So let's do a quick recap of what you just seen. So with Amazon TextRack, we ingested a handwritten prescription document, and this was flawlessly read by TextRack. And on the A2I bit, it was really effortless from the reviewer's perspective. The contacting the workers, providing them with the interactive user interface for them to review in, and consolidating that result upon it being done and save onto S3 bucket. A2I really covered that undifferentiated heavy lifting so that the reviewers can concentrate on the auditing the outputs rather than anything else that really doesn't matter to their business workflow. So with this, I'm going to pass over to Chris and to hear about how NHS BSA is using ML services on AWS to achieve their business outcome.
Thank you, Jihun. So firstly, just like to introduce yourself a bit further. So myself is Christopher Suter. So I am the lead infrastructure and connectivity architect for NHSx. But previous to that, I was the head of digital cloud platforms and innovation at the NHS BSA, or NHS Business Services Authority. Just give a bit of background here. So the aim of the NHSx within the NHS area is to drive forward the digital transformation of health and social care within the UK. And the use case I want to speak about today is an example that has been implemented within the NHS Business Services Authority. But first, I just want to take a step back here and actually introduce you to what the NHS is in terms of the National Health Service within the UK, which is a UK government-run body and is free to use to anybody in the UK at point of entry to get healthcare services, whether that be in the UK itself or UK citizens abroad. Covering a 66 million people population within the UK, but also expats living abroad or tourists who need to receive urgent medical care abroad also. And with this, it also helps support 1 million patients every 36 hours through its doors of its 7,000 primary care medical practices, or within its 350 plus hospitals located around the UK. A key part of the NHS ecosystem is the NHS Business Services Authority, whom are the behind the scenes heroes, making sure everything is working in regards to citizen facing services, primary care services, and actually the NHS workforce themselves. With that mission statement to be a catalyst for better health within the UK and drive health innovation forward. Under the remit set out by the UK's Department of Health and Social Care, they're responsible for looking after a majority of the UK NHS workforce, patient services outside of a medical care setting, and also UK citizens' interactions with the NHS, whether that be overseas or within the UK sovereignty. With the responsibilities and mission to be the catalyst for better health, the NHS Business Services Authority are accountable for £35 billion of the budget to fund activities in the NHS workforce, citizen area and patient services areas, while looking for efficiencies and cost savings within the NHS ecosystem, which they have successfully achieved, saving over £722 million since 2013. Alongside identifying savings, like I mentioned before, they also look after the 1.4 million NHS employees and process over 1 billion transactions or prescriptions each year for reimbursement back to pharmacists for claimed medical drugs and so on. And the prescriptions part is where I want to talk about today, and how we can extract that data from paper-based prescriptions into our delivery services using machine learning data. So prescription processing in the UK is similar to around the world. So your GP provides you a prescription which you then take to the pharmacy, but then that journey doesn't stop there. The pharmacies actually send the prescriptions to the NHS BSA for that reimbursement process, which is a 5-step process for the NHS Business Services Authority, which is receiving delivery of prescriptions, unboxing, sorting out these prescriptions into paid versus free, prepping these prescriptions ready for scanning, as you can see on the screen there, and then finally scanning these images, where it then can be uploaded, and then multiple services behind the scene extracted that data for payment and reimbursement. Just while I've got these scanners on the screen, I just want to tell you a little bit more. So these scanners can each run 16,000, 32,000 prescriptions per day, and of which we have 16 of these across the business in 3 locations. But behind the scenes of this, the NHS Business Services Authority has 3 sites, as mentioned before, with 300 members of staff, which are having to extract this data manually in some circumstances, whether that be handwritten or data which current OCR software can't pick up. So I just want to dive a little bit deeper here. As I mentioned before, the NHS BSA are responsible for processing these, which are roughly about 45 million prescriptions each month, and a subset of that, which is 18 million, which are paper-based. And just to give you some idea of scale about this, so if you stacked each one of these prescriptions on top of each other, it would equate to the height of 5 Eiffel Towers on top of each other per month. And the average payment of each one of these prescriptions is roughly about £20 to a pharmacist. And if you add all that together, would result in an approximate total of £9.4 billion reimbursed every year to them as a collective. And this represents 10% of the overall NHS budget. So, looking at what innovation we could drive in this space, we questioned ourselves. Can we extract data from prescription forms at a higher level of accuracy, but then also successfully leverage new technologies such as machine learning? So this is where we reached out to our friends at Amazon Web Services to help answer this question. And with that statement, identifying the challenges which we had to overcome. So the first one is scale. Like I mentioned before, this is 18 million paper-based prescriptions per month. We also have high operational costs. There's currently a large amount of people required to input, check and verify this well-regulated service which we provide, where these people could actually move to more fulfilling jobs within the NHS and serve the community a lot more better. There's also the flexibility. So we currently only have one work stream of scanning for these prescriptions, but the NHS has multiple paper-based systems which it has to manage on a daily basis. There is the diversity also and the variation of prescriptions out there. So one which Jihun showed you before was a normal GP prescription, but also we had to cater for dentists, hospitals and optometrists. And then also there is the elephant in the room, which is GP handwriting. Some GPs still prefer to do handwritten prescriptions, which we have to basically cater for going forward, which OCR technology doesn't have the skill sets to lift and extract the data in an accurate manner. Then there's also the ease of maintenance. This is an aging monolith service with a reduced number of specialists currently employed to look after it. And then finally, like I mentioned before, there's other use cases for this type of technology, not just prescriptions. The NHS have a wide range of paper-based forms which could benefit from this kind of process. So moving on, we have identified 5 requirements also. So like I mentioned before, the accuracy. We are a well-regulated industry of healthcare, which demands that high standards of accuracy of its data being extracted, processed and delivered for patient health and welfare. Also the effort, the 300 members of staff which is required behind the scenes to carry out this process. And as I mentioned before, the data extraction of GPs' handwriting, which is one of their main primary roles. The data itself. So we can actually extract more data from these forms, collect that data and better understand certain things such as population health within the UK. There is training also. So actually using this kind of technology, we want to build our own in-house capabilities to expand this service. Again, as mentioned before, to other use cases of paper-based forms within the NHS. And then finally, it comes back to the age-old argument of buy versus build. If we build our own, we have to have that maintenance, staff and understanding behind it. Where if we can buy from a service offering such as Amazon, we don't have to concentrate about it more and we can just more operate going forward and actually create less work for ourselves going forward, which delivers more benefits. So I just want to walk through the process, what we actually built together with Amazon. Well, first, let's take this high-level holistic view. So firstly, what we need to do to get these images actually into the system is actually scan them using our on-premise scanners, which you saw before, but then upload into the cloud. We then have to do a large amount of pre-processing there to get these images ready for uploading into the data extraction systems, carry out this data extraction on the printed and also the handwritten forms, carry out any auditing also, and correction that didn't pass the data extraction confidence requirements we have in this highly regulated environment, which I said before. Then also at the end of it all, allowing the data to be collected and used for a number of other activities, not just for reimbursement, but allowing data analysts to use this data to identify patterns and trends. So let's now have a look at these parts of these processes in a little bit more detail and the technical challenges we had in each one of these processes, what we overcome using our AWS technologies. So the first thing is pre-processing the image. So the challenge here, we had a large amount of images to process and also understanding the cost of impact versus the cost in terms of monetary value versus the performance, how many we can actually push through the system. Then also understanding whether we need a batch process or actually a real-time process going through. So one thing to bear in mind here is that there is an 18-day turnaround from receiving the prescriptions to actually reimbursing the pharmacist. So that allowed us to take advantage of batch processes and was, at the end of it, was our preferred option. So the solution here, as you can see, we have our on-premise scanners, which we then use Storage Gateway to upload the images which we scanned to the cloud, which then gets stored into an S3 bucket. With this S3 bucket, we can then take advantage of the S3 batch processing service and then pushing towards a Lambda, which would then clean up the image quality, ready for actually pushing through into the processing sector. This also allows the service to scale when demand is higher, whether that's due to winter pressures or currently because of the pandemic. So high and low throughputs can be managed gracefully, and the detailed pre-processing of an image can be maintained, and identification of the image, whether that's be a front or back of the prescription, can also be classified. Secondly of all is the extracted or printed data. So the challenge here was having a service that could meet our demands of high throughput, but then also be efficient on the cost and effectiveness when calling in this case the text extract service, in terms of course the API. So the solution here, following on from the Lambda, was to actually integrate this with an SQSQ. So queuing up the images ready to be pushed into Fargate, where Fargate would actually act as a metronome. So instead of trying to bulk upload thousands of images, Fargate would gracefully call the text extract API in a manner which was cost effective but also performant. This maximised efficiencies going forward in terms of the entire process and meets the need of an 18-day turnaround. Doing this asynchronously manner is the best route in our sense for performance and cost efficiencies. Thirdly, the fun part, the extraction of the handwritten data, whether that be from the front or the back of the forms which we have, and also identifying and extracting this handwritten data into certain parts. So understand that certain part is actually the data of the patient or the data of the drug. So the solution here, again following on from the text extract, was using an SNS notification, which would then identify whether that be the front or the back of the image and split that out into two separate Lambda functions. SageMaker would then pick up these and using custom models would actually extract the handwritten data going forward and push that back to the Lambda function where the data was stored in the S3. Sounds simple, but I just want to go in a bit more detail here. So, based off the confidence scores from text extract, the accuracy results from the front and the back of the images are sent via that SNS notification to the two different Lambda tasks. These Lambdas look at the accuracy results from each one of the fields in the text extracted data of the form. And with confidence scores being low, would send that to the SageMaker custom model. One thing I want to point out here is that times have changed. And with the use of text extract handwritten, we can actually replace that going forward. And I'll touch about that on a bit further. But firstly, this model identifies that there actually is handwritten on the forms and extracts that data where possible. And then, as I mentioned before, sends it back to the Lambda functions, which then says we have got that data and then adds it into the XML in the S3 bucket. The fourth part of it was the correction of the data and the auditing, which is really important for us. So, going back to a real world scenario, there is a lot of differences in the image quality of handwritten types, but also the image quality of actually the data being printed on the form. And with the high levels of regulatory requirements we have to make sure that we hit high targets. And also, we've got to think about not everything can meet them targets, so it will get dropped out. And this is where we need to start looking at actually introducing that human element to the process. Besides that, we also, again, being high regulated, we have auditing involved. So we need a third party to come and audit that everything we're collecting is at that high level and nothing's getting lost within the data extraction process. So the solution here, and Jihun touched about it before, was using A2I, so human in the loop, using the NHS Business Services Authority's highly skilled workforce for actually entering data of the extracted images, but then also carrying out auditing purposes to make sure that we can actually feed that back in and forward and reimburse the pharmacist. With the use of A2I, this enables our skilled workforce to input this information correctly that couldn't be read by either text extract or the SageMaker custom handwritten model. But also the human in the loop allows us to actually increase our accuracy ratings to 99% plus and allows third-party auditors to actually jump into our pipeline and our process instead of us extracting the data and send it to them separately. So keeping everything together, everything well audited going forward. So the solution summary altogether. One thing I want to point out is that we used AWS native tools throughout this process. So it allowed us to be scalable. It allowed a secure environment to be built, a decoupled environment, such as I mentioned before, removing services when a commodity service comes available, such as text-to-handwritten. It's fully serverless, And what's nice of all, it's cost efficiencies. We only pay for what we use. We haven't got that physical infrastructure on standby when we don't need to use it. So finishing off, I just want to mention that with all this, we simply have achieved the goals we set out and all the efficiencies which we wanted to gain. But we didn't stop there. The possibilities of this service for the NHS is remarkable. So making medical data on patients much more easy to be accessed by a doctor, nurse or care provider from all records which are handwritten. Flagging any outliers and anomalies in data that can be investigated further, whether that be in fraud or with an error within the system. Also allowing insights into population health from historic data. Enabling collecting data from different types of data sources. Like I mentioned before, the NHS has a large amount of paper-based forms within it, which we can easily import and use that data to help out going forward. And with that human in the loop, and allowing machine learning models to be retrained and become more efficient and increase accuracies with the data being extracted. I just want to thank you for your time, and I will hand over back to Jihun.
Yeah, thanks, Chris. Now, it's been 2 years since I worked with Chris on an AWS professional services engagement, and I'm still astonished at the sheer scale of their operations. I'm really humbled to be part of their journey to their digitization. Now, if you'd like to learn more about what it's like to have machine learning on AWS, please visit us at aws.training. Now, we have a lot of tailored courses depending on where you might be at on the journey. And there are a lot of real-world examples that you can follow along. But for more examples and for more information, please visit at the aws.training/machine learning. Now, thanks all for joining. And if you could fill out the survey towards the end, that'd be really great. Chris and I really would love to hear your feedbacks and comments. Thanks to all, and enjoy the summit.
The Fortinet Cloud portfolio helps safeguard apps and data in the cloud with a comprehensive security solution. You can reduce the complexity of managing multiple solutions and vendors with the Fortinet Security Fabric.